a square is inscribed in an isosceles triangle so that we have an isosceles right triangle, a square, so that the square and the triangle have one common angle. So let's draw the figure first, then we'll think about what is that we need to prove and all of that. So let's consider a triangle ABC, something like this, which is also an isosceles triangle. And then we have a square inscribed. Inscribed means what? Here we have the vertex being touching the sides of the triangle, all the vertex. Right, and one of the angle is common. So can we read the question again? A square, let's consider this, let's name it off. We have ABC and MNT. A square MNTB is our square, is inscribed in a isosceles right triangle. So we have an isosceles, that is AB is equal to BC over here. Isosceles right triangle, angle B is 90 degree. Show that the vertex of the opposite vertex of the square opposite to the vertex of the common angle. So common to both the angles is B. So this is your common angle. So what is that we have to show? The vertex of the common angle bisects the hypotenuse. Right? A vertex which is opposite to the common angle bisects. So basically we have to prove that AN is equal to NC. Okay guys. So first let's start off with talking about, let's consider triangle ABC, an isosceles right triangle with the following factors, that is angle B being equal to 90 degree, and so AB being equal to AC. We'll call this as X. Okay, let AB be equal to X and BC will also be equal to X. Okay guys, so why you learn in time, then again you know I like to use variables. Then also we have, it's a continuation, let MNTB be the square of side length being equal to a unit. Okay, so this lengths are a. Right, then we have, let B be the common angle. Okay, so I think all the initial things are given. So we are looking at to prove N is midpoint of, or N bisects AC. So indirectly N is the midpoint of AC. How can we do this? Quite a few ways. One of them being that triangle AMN is congruent to triangle ATC, and we are done. Right, we can clearly see they are congruent, is it not? Okay, so these two triangles are congruent. We just have to prove that. How will we prove that? Quite simple. We have this to be A, this will be A, and this will be A, and this will be A. So we have one pair of sides to be equal to each other. And then we have this to be 45 degree, this to be 45 degree, as it's an isosceles triangle. And then what else do we have? We just need one more angle, and that angle is over here, and this is 90 degree. And we are done. We have AAS. Okay, so this is one of the ways of proving that they are congruent. So proof begins with, so let's talk about angle A plus angle B First we'll talk about in triangle ABC. What do we have? We have angle A plus angle C plus angle B is equal to 180 degree. This is because of angle sum property of triangles. So what do we have? This to be angle A is equal to angle C, as we have opposite angles are equal when we have opposite angles of equal sides. Yeah, that's enough. Equal sides. And we have angle B to be equal to 90 degree. Therefore, angle A is equal to angle C will be equal to 45 degree. Okay, yes. So this two are 45 degree. And then we have, then what else can we tell? Then we can go on to telling Mn is equal to Nt, right? They are the sides of square. And then we can talk about angle AMN will be equal to angle ABC. Angle AMN is equal to angle MBC, right guys? Let me copy it off. If it's kind of confusing if we don't have the diagram while explaining. Okay, so these two angles are 90 degree, right? Or angle B, I can call it that also. So they are equal because they are corresponding angles of MN and BC being the parallel lines, right? So they are opposite sides are MN and BC are opposite sides of a square. Okay, so this is going to tell that angle AMN is equal to 90 degree. Similarly, angle NTC is also equal to 90 degree. Now, therefore, what can we tell? Therefore, angle AMN is equal to NTC. So we have all the things that is required and we just have to write the answer. That's it. Final answer being what? From 1, 2 and we have 3. So from 1, 2 and 3 with AAS congruency, what do we have? We have triangle. What is the triangle? AMN is congruent to triangle NTC. Okay. So with this we can imply, therefore by CP CT AN is equal to NC, thus N bisects AC. Hence proved. That's it. Okay guys. So this is your clear answer. This being A was not required. Again, see, I like to have the variables in case we need to prove. So I had some other thought, but I ended up using something else. So again, just understand that the writing part remains almost same throughout. You just have to get familiar with the concept and the properties. So what I'm trying to tell is I have not by hearted this. It's not pre-written. I'm writing everything naturally, and the ideas are coming out in front of you naturally because I have a good grasp of the concepts. So with that understanding, I'm putting it across. So that's what I'm trying to teach you guys. Understand the basics. Any random question you will be able to do, most of it at least.